This video we'll be discussing the math basics known as measurements. For this, we're just going to identify the different types of measurements that are commonly made in chemistry class. There are also ones that you have commonly used at home, so none of these should surprise you. Today we're going to talk about various units of measurement. We're going to talk about length, area, volume, mass, time, and something that we call just a number. We're going to look at some examples. We're going to look at it in the American system and the metric system and make some comparison. So let's start with length. We'll start with a few examples of how we might use length. So we might want to know, how long is this pencil? How tall is this table? Or how far is it to school? In the American system, we would say that the pen is 6 inches long, or we would abbreviate that as 6IN. We would tell you that the table is 3 foot tall, or again abbreviated 3FT for foot. And we might say that the school is 5 miles away, using the abbreviation MI for miles. In the metric system, we might say that the pen is 15 centimeters. The abbreviation for centimeter is cm. The table is about 1 meter tall. The abbreviation for meter is m. And that the school is about 8 kilometers from home. The abbreviation for kilometer is km. So as you can see, length is measured in a single direction. Next, let's look at area. Area is measured in 2 dimensions, the height and the width, or the length and the width. Some examples of when we might use area are to measure the size of a piece of paper, or possibly how much carpet you need in your house, or how big a piece of land would be. We might see that the piece of paper is about 94 square inches. There are 2 common ways to abbreviate square inch. We can use SQIN, or IN and then square that. In the metric system, we would see that this is about 600 square centimeters, and that would be abbreviated in one of 2 ways, SQCM or CM squared. Generally, we use CM squared. If you needed to recarpet your house, you might want to find out how much carpet you need. You might find that you need 10 square yards of carpet, and that yard is abbreviated YD, and then since it's squared, we're going to put YD squared. And in the metric system, that would be about 8.3 square meters, and again, that would be abbreviated M squared. For a piece of land, we might measure it as 1 square mile, which we would abbreviate as MI squared. If we were to look at that in the metric system, we might see that that is about 2.5 square kilometers, or km squared. So notice that no matter what measurement we do, if we're measuring area, it'll say square in some way. Now let's look at how we measure the volume. Volume determines the overall size of a substance. They are commonly measured in 2 different ways. One way uses solids that have a regular shape. The second method is commonly used for irregularly shaped solids like rocks, for liquids, and for gases. For the moment, we'll focus on the regular solids. For the regular solids, we can generally calculate the volume by measuring the length, the width, the height, and multiplying those. And thus we can see that volume measures the size in 3 dimensions. So let's look at a box, a bag of fertilizer, and the earth, and find their volumes. A small shipping box might be 100 cubic inches, abbreviated IN and then cubed, or CUIN. That would be close to 1,000 cubic centimeters, abbreviated CM cubed, or CUCM. A small bag of fertilizer is about 1 cubic foot of fertilizer, which is most commonly abbreviated FT cubed. That's only 0.03 cubic meters, abbreviated meter cubed. The volume of the Earth is about 260 billion cubic miles, abbreviated MI cubed. That's close to 1 trillion cubic kilometers, abbreviated km cubed. You might notice that all of these include the measurement something to do with cubic. When we look at liquid and gas measurements, it's not as obvious. You'll see that the American system has a variety of different things to measure volumes. Luckily, the metric system is more concise. So let's look at some of the volumes for milk, a storage bin, and an ocean. Think about the different ways that we use and purchase milk, and you'll get an idea of the variety of different things that we can use to measure the volume of a liquid like milk. I'm not going to list the actual numbers. I'm just going to list out a bunch of the different units and their abbreviations so that you can see what's used. The list will go from fairly small to a larger size. These are the common ones. We have a teaspoon, abbreviated TSP. A tablespoon, abbreviated capital T, BSP. Next we have cup, which is abbreviated C. Then we have pint, which is abbreviated PT. Then quart, which is QT. Then gallon, which is GAL. And sometimes people will use barrel, BBL, for liquids, but not usually for milk. We have one additional unit known as the fluid ounce. The fluid ounce is quite different because it depends upon the fact that whatever we're measuring should be composed of water mostly. I will not be using it in this course. The ways that we would normally buy milk or soda in the metric system are the milliliter and the liter. Milliliter is abbreviated ML, liter is abbreviated L. To get an idea of the sizes, we can see about 2 teaspoons is approximately 3 milliliters. And a gallon of milk is just a little bit under 4 liters, 3.75. To look at the volume of gas, like air, we often just look at the volume of the container. So in the case of a storage bin, the space inside of it might be a 20-gallon container. That means that there's 20 gallons of air inside. That's about 76 liters in the metric version. There are about 187 quintillion gallons of water in the Pacific Ocean. Again, that's quintillion, and yet we would still just write gal for gallons. And in the metric system, that's approximately 800 quintillion liters of water, or 0.8 quintillion kiloliters of water. You may have noticed that in the metric system, when we measure liquids, they're measured in some form of the liter. And the liter is our base unit. And now we're going to look at the mass of objects. Mass measures how much matter is present. But mass is only effectively measured in the metric system. In the American system, we actually use something called weight. The weight is dependent upon the gravitational force that is pulling on it. On Earth, we have the force of gravity from Earth. On the moon, we only have the force of the moon's gravity, which will make us weigh less. So here's a great diet plan for you. Just fly to the moon. The mass found in the metric system is independent of the gravitational force, so your mass will stay the same when you do fly to the moon. Mass is used when we buy things we want to know how much it weighs, rather than the size of it. So you'll notice sometimes in your cereal box it said it's sold by weight, not volume. That's because the volume changes depending on how crushed up your cereal is. But the mass remains the same no matter what. So a few examples for the American system would be gold, a steak, or an elephant. So if I were shopping for some gold, in the American system I might buy 1 ounce of gold, abbreviated OZ, whereas in the metric system I would have to buy about 28.4 grams of gold, and that again it has the abbreviation G. Now grams is our base unit. If I went shopping for a steak, I might buy one that was 1 pound. The abbreviation for pound is LB, or in the metric system I would buy about a 0.5 kilogram of that same steak. The abbreviation there is kg. An elephant weighs around 10,000 pounds, or 5 tons. In the American system, ton is abbreviated T. In the metric system, that elephant weighs about 4,500 kilograms. Notice that everything related to mass has the unit gram somewhere in it. Now it's time to look at time. Time measures either how long something took or when it will occur or has already occurred. Both the American and the metric system use the same basic set of units. In both cases, the base unit is the second, although we don't really use it in the American system. So when do we use these units? Well, you might look at how long did a race take, or when's your next meeting? When's the next birthday? Maybe you might want to know, when's the next century? How long away is it? Or maybe when will the next black hole form? For the race, we might look at how many minutes, seconds, or even split seconds that race takes. The abbreviation for minute is MIN. The abbreviation for second is S. The metric system allows us to use smaller measurements commonly. So we might say how many minutes or seconds, the same as we did in the American system, but rather than saying split second, we might say centiseconds, milliseconds, or even nanoseconds. Your next meeting might be in a few minutes, maybe a few hours, maybe a few days. Your next birthday might be in the next few days, next few weeks, or in a few months. The centuries might be measured in years or decades. The next black hole might occur in eons or millennia. Again, most of these measurements are the same for both the American and the metric system. It should be noted that all of these smaller units have second as a part of their unit. Again, the second is the base unit. And finally, we're going to look at what we mean by just a number. So finally, what does it mean when I say it's just a number? Well, this is something that doesn't have units, which means it doesn't have any kind of dimension. But it is a number that has some meaning to us. So if I told you that I have a pair of shoes, that would tell me that I have 2 shoes. If I say I have a dozen eggs, that means there are 12 eggs. Yet if I say I have a dozen cookies, that means there are 12 cookies. So the dozen means 12, but it doesn't tell you of what. A few other common numbers are things like a gross. A gross is 144. A ream, which is 500, neither of which you will see in this class. But we might see one that's called Avogadro's number, and that number is 6.02 times 10 to the 23rd, and it's a super important number for chemistry. But notice, it doesn't tell you of what. We'll talk more about that later. Now, these are not American or metric. They're just common terminology. They are not truly a measurement, but I wanted to put it in here so you see that it is numbers that you will see sometimes. So let's summarize a few things. First off, let's look at some of the measurements. We have length, which goes in one direction. We have area, which has 2 directions. And we have volume, which is in 3 dimensions: height, width, and length. When we look at these, we notice that the number of times that we do a measurement is once, twice, and 3 times. So it kind of gives you an idea of how many dimensions they have. We have 1 dimension for length, 2 dimensions for area, and 3 dimensions for volume. Next, we're going to focus a little bit more on the volume. So we're going to look a little bit more at this. And the main thing to notice is that there are 2 different versions. There's the type that we use with regular solids, where we're able to measure the 3 different dimensions: the height, the width, and the length. On the other hand, we can also use things that are made for liquids. Both of these are standard units. We use them commonly, super common, but it just depends on what type of substance we have. So again, we have the cubic ones. Those tend to be in the solids that are regularly shaped. And the irregular shaped ones, and the ones that are liquids or gases, tend to be measured down here in these other units where we would buy milk or soda. The next major item to know is that there are some very basic units that we use. So what we're going to see is things in the meters, when they have something with meter in them. All three of these have meter that has something to do with the measurement of length. In this case, it's just length. This one's length and width, and this one is length, width, and height. But they all have that same basic unit of meter. Then we could look at the liter, that is used for volume, grams, which are used for mass, and of course the second, which is used for time. Next, it's important to know what you need to know from this page. On this page, the main thing is to know what types of units you're looking at. You don't need to know all of the bits and pieces of it, but you should know that a gallon is a type of volume. You should know that something with a square in it, like square centimeter, is going to be an area, so that you can classify the type of measurement that's being made. You don't have to memorize how many cubic yards there are in a cubic inch, and you don't have to know any of the ratios of any of those. I will be providing the information you need for those. We're going to talk about that in the next lecture. But for the moment, I just want you to be able to classify what type of measurement I'm talking about when I give you some units. And finally, I'd like to mention some of the abbreviations that I often use for these types or classes of measurements. So for length, I usually use the letter L. For area, the letter A. For volume, the letter V. For mass, the lowercase letter m. We'll see uppercase later. And for time, a lowercase letter t. And finally, for number, I use the hashtag symbol, and it means something like a quantity. So you'll often see the word quantity, that means number. And that is it for the topic of measurements for today. We will move on to doing some metric calculations and what you need to memorize in the metric system. Again, you will not be memorizing anything in the American system, just know what type of measurement it is.